This video shows you how to get the surface area of a solid. If you cut out this shape on a piece of paper and fold it along the dotted line, you will be able to get a cube. What is the relationship between these 6 squares and the cube? You should be able to see that these 6 squares, it forms the total surface area of the cube. So the surface area of a solid is the sum of the areas of each of its surfaces. And this shape, known as a net, is a plane figure that can be folded up to form the solid. In the previous section, we know that the perpendicular distance between two bases of a prism is its. Now, before we fill in this blank, I just want to explain these two to you. So, base is actually referring to the cross-sectional area, and cross-sectional area is used interchangeably with the word base. Okay, please take note of that. So if the cross-sectional area of this cube or prism is identified to be these two, then the perpendicular distance refers to this, and it is known as its height. Okay, let's read the sentence again. In the previous section, we know that the perpendicular distance between the two bases of a prism is its height. Now, what about the other faces of the prism? If these are the cross-sectional area, the other faces are referring to these four, and these four are known as lateral faces, and they are shown in the cube as the unshaded parts. All right? And if you compare it with the net, you can see that in the figure above, the cube has 4 lateral faces. Please take note of this number 4, because in the lesson just now, I told you that there are 6 lateral faces. But what the note really want to say is that 2 of those are its cross-sectional area, and there are 4 lateral faces. Okay, so take note of that. Now, if you can remember, the video is to teach you how to find the total surface area of a cube. So the simplest method that we have learned is to add up the area of all 6 surfaces, and we start by looking at its cross-sectional area, which I'm going to identify as this one, as well as its corresponding cross-sectional area at the bottom. Okay, so if this is the cross-sectional area, this will be known as its height. Okay, so what is the area of the cross-sectional area? The cross-sectional area is a 2 cm by 2 cm square, so that's 4 cm square. Please take note of the change that I'm making here, because here I'm just talking about one cross-sectional area. Right? Now, what about the area of the lateral face? If this and this are identified as its cross-sectional area, there are 4 lateral faces left, and these 4 lateral faces, they are also 2 cm by 2 cm squares. So this will give me an area of 16 cm square. So the total surface area of this cube will be area of the lateral faces plus 2 times the cross-sectional area of the cube. The area of the lateral faces, we have found it just now, it's 16, and then we add it to 2 times of the cross-sectional area. This will therefore give us 24 cm square. Okay, so this is the traditional method we take out the faces one by one and then we add them up all together in the end. In secondary 1, we teach you a second method. Something that has got to do with the perimeter of the base. Okay, so first of all, we start to draw the base. Now, what is base? We've been using cross-sectional area all along, but now we switch to the word base, but you must understand that they mean the same thing. Okay, the base is this 2 cm by 2 cm square. Therefore, the perimeter of this base is equals to 2 times of length plus breadth. There are many ways to find the perimeter of a square. You can say 2 plus 2 plus 2 plus 2. You can say 4 times 2. They all mean the same thing. Okay, I just prefer to write it this way here. So this gives me 8 cm. Now, if I take this perimeter of the base 8 cm and I multiply by the height, if you can recall, the height is here, okay, which is another 2 cm. You can realize that this multiplication gives me 16 cm square. And what is interesting about this 16 cm square is it is actually related to an earlier value that we calculated here. See? And this 16 cm square is actually the area of lateral faces. So what do you notice about the value in A part 2 and part C? They are equal, right? So the values are equal. And what does it therefore tell you? Therefore, it tells you that the area of the lateral faces, can also be found by using perimeter of base times height. Perimeter of base times height. Alright? So if you can understand this, then here, what is the other way of finding the surface area using A part 1 and C? Where is A part 1? A part 1 is this. So if you have the cross-sectional area as well as the perimeter of base times height, how do you put them together to find the total surface area? Well, you should be able to tell me that the total surface area, or in this case, I just write surface area, it will be equals to the perimeter of base times height, okay, and then you add it to 2 times of the base.